It's up to you. All right, I guess we'll get started. I guess welcome to ML Mondays, week 6, recommender systems. So as you can see, we're nearing the end of ML Mondays. I know it used to be 8 weeks, but we had to consolidate week 5. I've been kind of vague about what week 7 is going to be so far, and I might have sent, there was like a poll sent out a while back that it's probably easy to miss on the AIS Discord. But week 7's topic is going to be decided by poll. So if you are interested in next week, there's a few topics that we could potentially go over, but I want to get the opinions of everyone else, so I don't, so I make sure I pick something that people are interested in. The deadline for the poll is going to be like tonight at midnight, so you can either do that now, not do it, it's up to you, or I'll put it on the Discord later after this presentation. But yeah. But enough about next week, let's actually talk about this week. We're going to be going over recommender systems. The idea is pretty straightforward. They're recommender systems. They're not, the name kind of speaks for itself. But we're going to go over a few different ideas within recommender systems and approaches to them, and then we're going to kind of build our own using basically one that can recommend movies using the movie lens dataset. As always, if anyone has any comments, questions, or concerns, please let me know. Makes things easier for everyone if we can do that, so I can fix any clarifications. So this is a very wordy definition that NVIDIA uses for a recommender system. I like my definition better. It's a recommender system. It's a system that recommends. It's pretty straightforward. So if you ever use anything like Netflix or anything like that, or Amazon, basically you've encountered a recommender system before. Based on your activities and activities of other individuals, the recommender system will recommend you things that it believes are good fits for you. So doing a really quick basic example, imagine there's person A, they give a positive reviews of Star Wars and Interstellar. So if some other person decides to search for Star Wars, they're probably going to be recommended Interstellar, because if someone shows interest in Star Wars based on this database, it's reasonably likely that they might like Interstellar as well, so they're going to recommend that. But this is the simplest example just to kind of get the point across. So approaching this a bit more formally, there's the end goal of what we're trying to do is to set up something called utility matrix. It's nothing too crazy. Basically, it's just for each user item pair. So in this case, it's movies, and basically there is a rating for each individual person and item pair. So generally, higher values are better, and those are the ones that we care about the most. High recommender values means that there's something that a person really likes. We don't really care if there's like a person that says, oh, I think this movie's okay. It's okay. That's not really that useful for us because no one's going to be, it's not a crazy thing. The higher value is what's important. Something to note is especially at the beginning, this is going to be a mostly blank matrix. This one's a little bit weird because there's actually a lot of data in here. But imagine if, say, 80 or 90% of this matrix is empty. That's how it's going to be to start with, because you're not going to be able to have hundreds or thousands or how many people rate every single item that they go through. No one has the patience for that. No one would want to do that. So the ratings are going to be mostly blank. So we have to make some inferences. We have to make some estimates. And that's kind of what the rest of this is for. So there's two real approaches to recommender. Well, there's a few more, but the two main ones are content-based recommender systems, and then later we'll go over collaborative filtering recommender systems. What a content-based recommender system does, it focuses on the items themselves and doesn't look as much into the user, other people's preferences. So it'll recommend items to a given person based on previous items rated highly by that same person. So basically for this one, it's pretty important to have a good idea as to what your items do. What items are. Because in order to determine if items are similar, you have to make sure that you know what the items are. So there are some simple ones you could say. I think the best one here is probably genre. If someone really likes the fantasy genre, it would make sense for them to be recommended things in that genre. If you want more detailed things to go over, you can always do things like text mining and stuff to extract some useful information. It's a little bit subjective in terms of how you get good features. That's one of the main downsides of this, but it can be nice in that you can be really specialized with your approach. So how do we actually determine if things are similar? Math's not too scary here, but basically, we just have to, basically you take an item and you make it into a vector of features. So in a really basic example, you could have some kind of vector which just says what genre something is. So let's just say there are 10 possible genres. So there's like 10 values in the vector. They could all be 0 or 1, whether something's a certain genre or not, because there might be a movie with multiple genres, for instance. That's most movies actually. Like there's going to be an action thriller or something like that. There's going to be multiple things. If you have things that are similar, then this expression will end up being higher for two different items that are very similar in that measure. If it's low, then it's very dissimilar, and that's stuff we don't care about as much. Basically, item profile plus user profile is a prediction. Does anyone have any questions about this before I move on?
Is there like actual AI being used? Like, is it just like comparing like the actors?
So that's actually a great question. I guess that's okay. So I should probably start by mentioning that this is AI, but I would argue that this isn't machine learning. This is one of those weird areas where it's kind of in between. There are things that are machine learning based with it, like more complex versions of these approaches do use actual machine learning. I'm going off of the basics for now, but it's kind of in that weird area where it is intelligent, but it's like, and it is kind of machine learning too. It's not like a neural net though.
It's just like comparing the vectors.
In this case, yes. Though it is learning the more data it gets. So if you have like additional, if you have more like ratings of a person, like if you've ever seen like any like Netflix or Amazon, for instance, it might say, would you recommend this item given that you've gotten this? And it can kind of correct itself using those values. So it's kind of different AI/machine learning, but it still is. It's definitely different from a lot of what I've gone over in the past 2 weeks though. Any other questions about anything I've gone over before I go further?
Size are available on Discord.
Yeah, well, they'll be on Discord. I haven't put them on there yet, but there will be. Okay, I'll move on. All right, the other big option we have is collaborative filter. So this is basically going off of the other approach. Instead of going off of items, you go off of users. So if we have a lot of users in our thing, let's just say there's like hundreds and hundreds of users. Some of them are bound to be similar to each other in terms of their preferences. And if one person really likes a certain set of things, then we can kind of make some guesses that similar people might enjoy similar things. But that's the idea. There's some math. Frankly, this isn't super important because a lot of this is dealt with in the background. But essentially, there is a number of there's a number of ways to kind of determine the similarities between users. I mentioned before there's a cosine similarity. This is the same here. There's some other options as well. Frankly, it's not that important. They all do something similar unless you're like, you can always like kind of choose between and see which one's the best for your specific use case. But that's the idea. As a reminder, this is all generally done for you by existing libraries, which is something I'll demonstrate in a bit. But yeah, basically, what we're doing here is we're basically taking a set of users that are similar to our user, like a certain limited set, and we'll only consider, say, 10 users that are similar to us. And then from there, we'll see how their ratings compare to ours. But it's basically just filtering out some content. So, a lot of text here, but the main idea is content-based versus collaborative-based filtering. There are pros and cons to both. Generally speaking, a lot of like the nicer recommender systems use some kind of hybrid approach where they combine the info. That does complicate things, but it does allow for a more holistic thing. You can avoid certain things. From some of the stuff I said before, there is an issue of like, for instance, popularity bias for the collaborative approach, where if you have a bunch of users that think a particular thing is popular, you're just going to assume that the next person also likes it, even though that you're kind of assuming all is the same, when in actuality it could be quite different. Content-based can handle more specialized tastes a bit better, but at the same time, they're over-specialized. So there has to be a mix, if you want to do something like really well. But both of these options are reasonably good. Some people just go as simple as take both approaches and use both results. But does anyone have any questions about what I've gone over so far? I don't have a ton of specific content, but I will be going over the workshop, which should hopefully give you more of an idea of how this works. All right, then I guess we'll get going. So, wherever has a computer, there's a QR code for the workshop. If you can't access this QR code for some reason, I can put the share link on Discord, but please let me know if you have an issue with this. Okay. So if the QR code worked, you should see something like this. Is anyone not seeing this? Okay, I'm going to assume that's a yes. So as with all the other workshops I've done, if you want to actually be able to modify this, I'm going to need you to save a copy in Drive. So click on that, and that'll actually allow you to edit this. All right. Now, because this one generally doesn't take super long, so the GPU isn't super important to use, but just for a good practice, I'm going to remind you all how to use that. So if you go to runtime, change runtime type, and then go from none to GPU for the hardware accelerator. It won't be as necessary for this particular workshop, but if you're, yes.
Do you have the link for it?
Okay, the QR code wasn't working. I can give you a link.
Okay.
Bear with me. Okay. Actually, it might be easier to. I'm going to stop sharing for a moment. Okay. The link should be posted in the resources channel in Discord. Let me know if you can access that.
Okay, that works.
Okay, cool. Then we should be good to go. Gonna represent real quick. So, because you didn't see that, I do need you to go to File and then save a copy in Drive, so that way you'll actually be able to edit what you're doing. And then, again, not necessarily for this particular workshop, but in general, for anything machine learning, you want to go to Runtime, change Runtime type, and then set Hardware Accelerator to GPU. That'll speed things up in most cases. So, raise your hand if anyone has not gotten to this point. Okay, so everyone has? Then we're good. Okay, so for this workshop, we're going to be using the Movie Lens dataset, which is the dataset of a bunch of user reviews of movies. And we can use that to make a recommender system. So first, we got to do some setting up. We're going to be making use of a module in Python called Surprise. It's a weird name. Basically, it just has a lot of stuff for recommender systems in it. Makes things a lot easier. You will need to, this first install might take a bit, but the rest shouldn't take super long. But once we have that in there, we can keep going. But while we have this started, we can kind of look into the data set for a bit while this is all loading. So this data set's not organized trivially. It's a bit interesting. None of these things are going to run now, but I still have previews of what they were. The data set consists of a lot of different files. Most of those are just for train test splits that we, as the users, aren't going to mess with directly. But just for your own interest, u.item has a lot of stuff concerning basically info about the movies. Most of the information is going to be about genre. That's most of the interesting stuff. But for instance, the top 10 within that item, within that file, it looks pretty straightforward. There's Toy Story, year, release date, similar info, and then you'll see a bunch of zeros and ones. Those are basically Booleans, ones or zeros, to determine if they're a particular genre or not. So for instance, this first one has 000111 and a bunch of zeros. That would make it a children's animation comedy, which, if you've ever watched Toy Story, I think that's fairly accurate. But I think at this point, the installation's done. So we are going to load that data set. It'll probably prompt you to download it because it's not in the collab by default. Doesn't take very long though. It's not a huge data set, so will work. We can kind of skip this other stuff for now, but basically it just gives you information about a few of the more interesting files in case you want to actually go in and dive a bit closer. But I'll skip this. So actually building our recommender system. We're going to be using Surprise. Just for clarification, it uses a form of k nearest neighbors, which is it's kind of similar to what we've already kind of been talking about. It's an algorithm that makes use of the k most similar users or items to something else to make a prediction. So that's why it's called KNN baseline. It's like a baseline setup, which uses that kind of KNN approach. We can keep the sim options as is for now, but we can kind of go back and mess with those. But we're basically setting up our algorithm to, training takes really, it doesn't take long at all, very fast, to basically take our training set and get some predictions of that. So by default, it's not very easy to get very simple predictions, but there's a workaround to that. If we actually want to know individual predictions without relying on, the error for the entire data set is blank. That's not very helpful for us, at least in terms of understanding. We can do a little bit of experimentation. So this function right here, it's not super important that you understand it, but basically it's just a way of converting IDs to names and vice versa. So when you do mess with things, we actually see a movie name and we can connect the dots as opposed to saying movie 35 is similar to movie 89. That doesn't tell us anything. So getting that in name form is great. So just running a couple cells, I mean. So we can experiment a bit. There are a lot of things you can do to kind of mess with this, but this code is an example of how you can get the 10 most similar neighbors, in this case, 10 most similar movies to a particular movie with our system, with our data set. So for this particular movie ID, it's 100, so we'll just run this real quick. So it'll show, according to our data set, which is imperfect, the top 10 nearest neighbors to Fargo are so and so and so. If you change the ID a bit, it'll give you different results. There's not a whole lot of IDs, and some of the IDs are weird, so it might give you an error if you try something strange for the ID. But you can see a bunch of things, and it'll kind of give you an idea of how this actually works as opposed to just going off and up. So we can actually put this on our test data set now. If we were to run this real quick, it would do some predictions, and it would give a result which is basically it is a measure of how well our algorithm did. It uses something called root mean squared error, which is basically it's just taking the worse our predictions are, it'll penalize us a greater amount at higher levels. But if you didn't change anything, the results would be about 0.48. Lower numbers are better here because we're trying to minimize error. So if we want to actually change this and make this more of a workshop type deal, then we can do some things. So I mentioned before how there was a whole sim options thing. It's a dictionary that we put up here. So we can mess with that a bit. So you could see how this is, there's a user-based and it says false. So that would make it item-based, which is the content-based approach that we talked about before. You could also set that to true, and that would make it user-based approach instead, or collaborative filtering. So you can kind of mess with that. That's significant. I'm going to run that real quick to see how it is different. But it doesn't take too long to do because this is a pretty fast data set. But it will be different. Taking a little bit longer, but anyway, once that's actually okay. So it is slightly better for the user-based approach in this case, though it is pretty similar, so it's not a huge difference. There are also some other options. So for instance, you can use a different similarity metric. I went through this in passing during the slides, but you can do a few different options. Again, this is just a matter of, a lot of this is experimentation until you get an intuition of how well different things work in different situations. You can kind of just play with it. A lot of these, there's not necessarily a clear wisdom on all of these things, but it's nice to mess with. And then this wasn't in the sim options dictionary up here, but there is another option you can put in. It's something called min support, which basically this is how many items or users you would need for a given. So I mentioned before how. So if I go back to here. There's basically a function that takes in a set of users most similar to K. X is rated out of mine. It's a little bit of a mess, but you get the idea. We could kind of set n to be a certain size, be a certain minimum size, so that way it doesn't over specialize as much. If we set it to a higher value, we can force the involvement of a lot more users, and we can get a more holistic approach, but it does come at the cost that maybe including users that aren't so similar. But the option is there if you do want to mess with that. There are some other things I could go over, but it's a bit more messy to talk about, but I only went over KN and baseline. There are some other options as well that might give you some better results. If you were to go to that site, you'd learn a bit more, but basically it would just be a matter of importing and using different sim options. I know I went over that all kind of fast. Does anyone have any questions about this?
So the data set is like built in, right?
The data set is what?
Is it built in or is it
So-
something that you import?
So this particular one is built in. There's like there's 2 working data sets that are built in. I tried a third one a few days ago that is not working, but this one is built in. It isn't super crazy to make your own to put in your own data set, but as you can see from how this data set's built up, it isn't nearly as simple. It's a bit more messy because that file structure isn't super obvious as to how it works. So this one's built in, yes. If you were genuinely curious, I think there's also the other one is 1 million. So the other one was 100,000 ratings. I think this one is like a bit of a larger data set, which might be nice. I think the actual full data set is much larger than this, but it is publicly available. So this is our sample. But if that answers your question.
Does like importing a data set from a Tableau or something, does that make building a recommender system like harder? Or?
Like a bit harder, but there are definitely approaches. I mean, the 2 data sets I've shown are those are the only data sets that are built in. This would be like completely unworkable if there was no way to use anything besides those 2. That works. There are sites out there that can like show you how to do it. It's not too crazy. So if you want to mess with it, you can. Still surprisingly do a lot for you even without even if you weren't using Ruby Lens. Does that answer your question?
Yeah.
Okay. Does anyone else have any questions? Okay, then if that's the case, if there's nothing else, if anyone has any particular questions for me, we can do it after the recording, after I start the recording. But yeah, I'll put this all in the Discord as a reminder. Fill out that poll if you want to have a say in what we do next week. And yeah, have a good one.